This is an actual sketch made by Isaac Newton. It shows the paths of a cannonball fired at different speeds from the top of a hypothetical mountain. Newton asserted that if fired fast enough so the curved path of the cannonball matched the curvature of Earth, it would fall indefinitely. Here's a similar sketch. Let's call this Newton's mountain, which we'll imagine is high enough to be above the effects of air drag. Let's put a cannon at the top of the mountain. If there were no gravity, then a horizontally fired cannonball would follow a straight line path. But there is gravity, so a fired cannonball would fall beneath this straight line path. Let's fire one. Little higher speed. Higher speed. Let's fire at really high speed. My goodness, look at this. The cannonball would... Got to get the cannon out of the way. But the path matches Earth's curvature, and the cannonball falls all around the Earth without ever touching the ground. It's an Earth satellite. Newton made calculations of what this speed would be and realized that cannonballs could never be fired that fast. Rocketry wasn't the order of the day back then, and certainly he wasn't hip to multi-stage rockets. So Newton did not envision humans ever putting satellites in orbit. What was the enormous speed that Newton calculated? I think you can calculate that speed also in your head without a calculator if you let me guide your thinking a bit. There are two things you need to know. Number one, that an object falling beneath a straight line path falls a vertical distance of 5 meters in its first second of fall. That's the distance an apple would fall in 1 second if you dropped it from the roof of your house. The second thing you need to know is how round Earth is. A geometrical fact about the curvature of Earth is that its surface drops a vertical distance of 5 meters for every 8,000 meters tangent to its surface. 8,000 meters is 8 kilometers. Consider a portion of Earth in a desert region where the land is flat and without obstructions. Let's mount a laser on a tripod about 1 meter above ground level and shine a laser beam horizontally out across the desert floor. Due to Earth's curvature, the beam downrange would be higher above the ground than at its starting point. At 8 kilometers downrange, the beam would be 5 meters above its starting level. This may prove interesting. Now suppose we replace the laser with a super cannon, one that can fire cannonballs with incredibly high speeds. Furthermore, we pretend there is no air resistance. What we want to do is calculate what Newton calculated, but in a different way. To begin, suppose we fire the cannonball at a speed of 2 kilometers per second. Then at the end of 1 second, with no Earth gravity, the cannonball will have reached 2,000 meters downrange. That's 2 kilometers. But there is gravity and it falls below this point. How far? That's right, 5 meters. But it would hit the ground before this happened. If the cannonball were to be airborne during this time, we'd have to dig a trench in the sand. Clearly, 2 kilometers per second is not fast enough for orbit. Let's fire the cannonball at twice the speed, at 4 kilometers per second. This time, the cannonball travels 4 kilometers during this second. But again, it would hit the ground before 1 second elapses, unless we dig another trench. I hope you can see where this is going. Let's try 6 kilometers per second. Is this fast enough so that we don't have to dig another trench? No, again, we'd have to dig sand out of the way, but notice, not as deep. Is there a speed wherein we don't have to dig a trench at all? And what is this speed? Can you see that if it gets 8 kilometers downrange in 1 second, and falls 5 meters below where it would go with no gravity, that no trench would be necessary? What's the speed? I hope you said 8 kilometers per second. At 8 kilometers per second, it never touches the ground. Note something interesting. Since there's no air drag to slow it down, when the cannonball gets to the 8-kilometer distance, it's moving just as fast as initially. So it would repeat falling beneath a new tangent every second. Unless some force interrupts it, it would fall indefinitely. It would be an Earth satellite. Yum. Now 8 kilometers per second doesn't sound fast, but convert it to miles per hour and you get 18,000 miles per hour. At higher elevations, orbital speed is less. For example, the International Space Station orbits at an average speed of 7.7 kilometers per second, a bit less than 8 kilometers per second. Is the space station above Earth's gravity? No. What it is above is Earth's atmosphere, most of it anyway. Because of slight air drag, every once in a while, the space station has to be given a boost in speed. Astronauts inside are in a continual state of free fall, which feels like there's no gravity. But Earth gravity at that altitude is nearly 90% of what it is here at Earth's surface. Without it, the space station and all Earth satellites would fly off into straight-line paths. Let me leave you with a question. Why does a satellite in circular orbit maintain a constant speed? And tie this to your answer as to why a bowling ball rolling along an alley also has a constant speed. Both the satellite and the bowling ball are pulled downward by gravity. So why don't they speed up? Until next time, good energy.